Reaching for the stars. Why rocket staging matters. Space is hard. It's not just a matter of going up, we need to go really fast to escape Earth's gravity. This takes a lot of fuel, but carrying all that fuel makes the rocket heavy. This is where rocket staging comes in. It's like a brilliant trick we play on gravity. Imagine a rocket shedding its weight as it climbs higher, becoming lighter and more efficient. That's the magic of staging. Staging is crucial for space exploration. It allows us to send heavier payloads farther into space. Without staging, we wouldn't have reached the moon, sent probes to other planets, or built the International Space Station. The multi-stage marvel, a symphony of power. Rockets are the epitome of human ingenuity and engineering prowess, combining raw power with delicate precision. Think of a multi-stage rocket as a team of powerful athletes, each with a specific role to play. Just like in a relay race, each stage hands off the baton to the next, ensuring the mission continues seamlessly. Each stage is a self-contained rocket with its own engines and fuel. Engineers meticulously design and test these stages to ensure they perform flawlessly. As each stage completes its job, it detaches, allowing the next stage to take over and propel the rocket further. This process is a marvel of timing and precision. The most common type of rocket has 2 or 3 stages. These configurations are optimized for different types of missions, from launching satellites to deep space exploration. The first stage is the workhorse. It provides the initial thrust needed to lift the rocket off the ground, battling against gravity and air resistance. It lifts the entire rocket off the ground, battling against gravity and air resistance. This stage must generate immense power to break free from Earth's gravitational pull. Once its fuel is spent, it separates and falls back to Earth. This separation is crucial to lighten the load and allow the next stage to ignite. Now, the second stage, smaller and lighter, ignites its engine. This stage is designed to operate in the thinner atmosphere where it can be more efficient. It doesn't have to fight as hard against gravity anymore, so it can accelerate the rocket even faster. This stage ensures the payload reaches the edge of space. This stage carries the payload closer to its destination. Whether it's a satellite, a space probe, or a crewed spacecraft, this stage is crucial for mission success. Some rockets have a third stage, even smaller and more efficient for that final push into orbit or beyond. This stage ensures the payload reaches its precise orbit or embarks on its journey into deep space. The ascent, a stage-by-stage breakdown. Let's visualize a typical 3-stage rocket launch, a marvel of engineering and precision. Stage 1, the heavy lifter. This stage is equipped with powerful engines and massive fuel tanks. It roars to life, generating immense thrust to overcome Earth's gravity. The engines burn through thousands of gallons of fuel per second. The rocket climbs skyward, leaving a trail of fire and smoke. This stage is crucial for breaking through the dense lower atmosphere. Stage separation 1. Once the first stage's fuel is depleted, explosive bolts detonate, separating it from the rest of the rocket. This process is meticulously timed to ensure a smooth transition. The first stage falls back to Earth, while the second stage ignites its engine. This stage is designed to operate in thinner air. Stage 2. With less weight to carry, the second stage accelerates the rocket further, pushing it higher and faster. It continues the journey through the upper atmosphere. Stage separation 2. The second stage completes its burn and detaches, revealing the final stage, which carries the precious payload. This separation is critical for the mission's success. Stage 3. This final stage, highly efficient and optimized for the vacuum of space, carries the payload to its final destination. It is designed to operate with maximum efficiency in the harsh environment of space, whether it's a low Earth orbit, a distant planet, or beyond. This stage ensures the payload reaches its intended orbit or trajectory, completing the mission. Section 4. Detachment, the art of letting go. Timing is everything in rocket science. Stage separation is a critical event that must happen at precisely the right moment. If a stage detaches too early, the rocket might not have enough thrust to continue its journey. If it detaches too late, it becomes dead weight, hindering the rocket's progress. Engineers carefully calculate the optimal moment for stage separation based on factors like fuel consumption, altitude, and velocity. When the time is right, a sophisticated system of explosive bolts triggers the separation. Section 5. Explosive bolts, the unsung heroes of space travel. Explosive bolts are ingenious devices that use a small, controlled explosion to separate rocket stages. They are incredibly reliable and designed to function flawlessly in the harsh conditions of space. Here's how they work. First, each bolt contains a small explosive charge carefully contained within a metal casing. Then, at the precise moment for separation, an electrical signal triggers the explosive charge. The explosion instantly creates a shock wave that breaks a pre-weakened section of the bolt, separating the two stages cleanly and efficiently. Explosive bolts are essential for the success of any multi-stage rocket launch. They allow for the precise and reliable separation of stages, ensuring that the rocket can shed unnecessary weight and continue its journey into space. Section 6. The impact of staging reaching new heights. Rocket staging has revolutionized space exploration, fundamentally changing the way we approach the cosmos. By enabling us to build more powerful and efficient rockets, staging has made it possible to explore our solar system and beyond. This innovation allows engineers to design rockets that can discard parts of themselves during flight, making the remaining structure lighter and more efficient. Here are some of the key impacts of staging: increased payload capacity. By shedding weight as they ascend, rockets can carry heavier payloads into space, including larger satellites, more sophisticated probes, and even humans. This means we can send more equipment and supplies on missions, enhancing our ability to conduct scientific research and exploration. Greater distance staging allows us to send spacecraft on longer journeys to distant planets, asteroids, and beyond. This capability has opened up new frontiers for exploration, enabling missions to the outer planets and even interstellar space. Reduced cost. While building a multi-stage rocket might seem more complex, it's actually more cost-effective in the long run because it reduces the amount of fuel needed for a given payload mass. This efficiency translates to significant cost savings over time, making space exploration more sustainable. Without staging, many of humanity's greatest space achievements would not have been possible. From landing on the moon to exploring Mars and beyond, staging has been a cornerstone of our journey into the final frontier. Section 7. Conclusion: the future of space exploration. As we push the boundaries of space exploration further, rocket staging will continue to play a vital role. Engineers are constantly developing new technologies and designs to make rockets even more efficient and powerful. From reusable rockets to innovative propulsion systems, the future of space exploration promises to be even more awe-inspiring thanks to the ingenious concept of rocket staging.